Hi guys and girls, Emma again. Welcome back to the spare room. In the last video, at the end of the last video here, I meant to set this up and drill it. Set this up and I drilled it to the minimum size to the reamer. Now I found a reamer. This is an old stock reamer that's pretty nice, and number 6. That'll just enter in there. And because a metric reamer is a different taper to an imperial reamer or to a British standard reamer, just check that, and there's no rock there, so I'm pretty convinced that that's 1 to 48 in the hole and 1 to 48 on the reamer. If it's not, well, they're both the same, so it doesn't matter, but I'm guessing that that's what it should be. And it's taken me a little bit, and I've spent a bit of time thinking about this. How do we get this pin so that it's in exactly the same position on the other one as this one, so they're interchangeable? What I'm going to do is put a Sharpie line on here. I'm probably going to move it out about 1/8 of an inch and put a Sharpie line on it. And then we're going to ream this one till it fits, and we can take it out then and we can just finish it up by hand if we need to. So I'm just going to mark that so we've got a diameter to go to, like so, and we need to ream that until that fits into that line, or a little bit shy of it, somewhere near that line, and then we can take this out and we can see if it fits in the machine, and we can round the top over and we can finish it off afterwards. So main job tonight is to get this out of the lathe so we can use it for something else. We want probably a much slower speed than that, I reckon, so I'm going to wind the VFD down a bit. And try it at that. I reckon that's not bad. That's right on the line there. It's probably good enough. There's no wobble in that. I'm really pleased with that. Time to slip this out and start with the test fit. We're brave. There we go. So more by luck than good management probably, I've got this where I think it needs to be. It's a fraction tighter, I think, than the other one in the bore. If we have a look, this one goes into there, which I've marked there, and that goes into there. The new one doesn't quite go in that far. So there's a tiny gap there. So it's a couple of thou tighter, which it probably needs to be if it's worn. The other one's worn. Putting that in that locates nicely in there, and there's not a lot of wobble there. Pretty happy about that. However, right, oops, knock that out and put this on here. This doesn't go in far enough, or doesn't go in far enough for this to come out the other end, and it certainly doesn't go in far enough to locate on the hole. It only needs, I reckon, about probably 10 thou off the back here, and I'm going to do that next. You see that 10 thou off the back here. I'm going to do that next. Set it up in the middle again and just take 10 thou off and see how it fits, and just get it so that it goes in nicely and it feels like there's not a lot of wobble in it before I start to shape this around here. So that's the next job, is to clean that up so that that pin goes in the same distance with it down flat there as it does when there's a gap behind it. There's a gap there on the top, and that goes into about the right spot. So next job really is to clean that up so that when I sit that in, I probably said that already, that goes in the right spot. So whether I'm going to get that done tonight, I'm really not sure. Let's see how we go. So there we go, that's in. It's about where it wants to be. I think it might be a fraction loose. I only took about 1/8 thou off there, something like that. It didn't need very much at all, but that's about, I think, how the other one is. There's not a lot of wiggle in there really over the length of the thing. It's probably, might be 10 thou. I'm pretty happy with that. Next job's around the top over. So a set of radius gauges, and that's 3/4, so if we go for 3/8 and just have a look and see how that measures up. The amazing Mr. Andy Richard scribe. And we probably want to finish that to about that circle, I think. A couple of ways we can do that. We could do it in the mill without a lot of hassles at all, and that's probably the best way. Or we could do it in the shaper with about as many hassles. However, if I set this up in here, I'm not sure that this vise is going to hold enough of the block here. So I'm going to do it in the mill. I'm just going to take the corners off, probably in 4 positions, something like that, so it cleans up. And then I'm going to round the top of it over with a file. So I've been roughing this down, and I've got this pretty nice and parallel, and I've set this all up and trammed it in place. That's about 22.2, I think, millimeters, which according to my measurements probably isn't far off where I need to be. And I think that's probably a fraction tight, if anything. It's a good fit there. I think we could take another 0.1 off there comfortably. That's a push fit in there, and pretty pleased with that. But I'm not really looking for a push fit. So running this pretty quick. And I'm only taking another 0.1 off the diameter, something like that. It won't be very much. There's no power feed on this machine, but if we take it nice and steady and slow, and that's pretty jolly good on there. That's where it needs to be. Still a bit of a burr on there. That might be a fraction big. But it fits nice all the way around. So it's all eccentric. It's all concentric and everything. So I'm going to just clean this back up here and clean that up. Next job is to take this down to we're going to use these same bolts, which I think are probably 3/8 Whitworth. I probably should check that. There's 3/8 Whitworth bolt. I'm going to make exactly the same bolt for here. And that way the spanner fits everything, which is good. Not that we've got a spanner yet. That's also on the project's list. So the end, sort of 1/2 inch of 3/8, probably the end up 3/8 of an inch, wants to be down to about 18 millimeters, which is the distance across the hex here. I think it wants about that on it to look good. This is 22, so that's 4 millimeters off. So I might just take that down now, and we'll see how it looks. So I made a form tool there. Oh, I had a form tool there that I made up. I've just used that to round that over there a bit, just so it looks a little bit nicer. And next job, I guess, is to drill in and tap this 3/8 Whitworth. That's 3/8 16. I've got plenty of taps. Whether any of them actually cut will be a completely different sort of a ball game. And of course that thread's nowhere near like 3/8 16. It's more like 3/8 20 or 3/8 18. So we found a tapping drill size, and I reckon this is probably running a little bit too fast, so I'm going to run this belt over here. Need a new drive belt on this lathe at some point. I found a new 3/8 16 tap, which I'm pretty impressed about. Usually my Whitworth taps tend to be old and like 4 or 5 generations old, and haven't seen much daylight or good service or busy service in the last generation and a half. The only real operation to do now in the lathe is to part this off, and nice straight parting tool that's right straight into the work and right on centre height is important. Plenty of lube, not too fast, and plenty of horsepower. And there we go. I'm going to face the back of that off because I've got to set it up in the vise nice and solid in the mill. This is probably hot, is it? No, it's not too bad. And I suspect that this surface here is going to be concave from where I parted it. So I'm going to machine that off and just leave a little bit on the outside and sink the middle down a little bit. And that way, hopefully, it'll sit nice and solid on the vice jaws and not rock around or move. So a little bit of preparation here is probably going to make a big difference to the sort of work that I'm going to do on the next operation. Well, there's been some discussion about this, how I'm going to cut the slot in this finished lantern. This is the part that I have. That's what it looks like. It needs a 1/2 inch slot from there to there. Not a big deal. It's Friday night. I've got to work tomorrow. I'm going to do a little bit of this tonight. It won't be very much. Piece of paper there. And a piece of paper there so it grips nice. And do it up nicely in the middle of the vise, I think. And that's pretty square. I don't think it's going to move much. We nip this up. I'm pretty happy with the way that that's gripped there. I don't think that's going to move. I've got an edge finder, just the same as any other mill, or vertical mill, or whatever else. The only difference is that on this mill I don't have any vertical adjustment. Or any quill feed. So I'm just going to wind this up until we reckon we're pretty close to the centre, or pretty close to this top edge. It's just popped in. You see that edge finder's just popped in nicely there, and it's popped out again there. And I reckon that's pretty close to centre. So if we lock that up, wind this out here, stop the mill, and I believe this wedge finder's 3/8. We probably should check that before we go much further. It's not even close to 375, so let's find a metric. Find a metric micrometer. And it's exactly 10 millimeters. So centre height here is 5 millimeters. The centre height of the spindle is actually 5 millimeters above the top of this. If we measure this, we're 22.1, which was about what I thought we were. So to come down to the centre, we need 10.1 and 5 millimeters. So 15 millimeters it's got to drop. 15.1 millimeters. Of course, Google's our unbeatable friend, and type 15.1 to inches in Google and you get 400. And you get 590 thou. That's got to drop down. So I'm going to take this out. I found a carbide end mill, which probably isn't the best choice because this milling machine really isn't fast enough in this mode to do this. It has potential to be, and it will be one day. There's some extra gearing on the back that needs belts and a pulley so that it'll run pretty quick, and that's what it needs to do. But right now it's only doing nowhere near enough revs anyway. So this needs to go 595 thou, we said. So there we go, it's 595 thou, and we should be right on centre. Next job really is just to touch off. This is a through hole. I had thought to drill a row of holes here, but I haven't really got enough length here in the between the chuck and the work to do that, and I think it's going to move with that sort of pressure. So just touch off and we'll see how even the mark is and how it looks. So this is where it all comes unstuck. I've encountered a problem that I was aware of, but doing this job it didn't occur to me. I was sure that I had this sorted, and the more you think about it, the more muddled you get until you actually go to do it. But 3 guesses to anyone, pause now and come back to this later if you like, and tell me what the problem is. The issue is, say it now, is that this runs anti-clockwise from this direction, right? So we plug it in, and looking at it from this direction, it runs clockwise. But looking at it from the other direction at the top of the drill, it needs to run anti-clockwise. So this drill mill to operate in this configuration really needs a reversing motor. Now I don't have that, and I have plans to fit that at some point, but at this point it's not happening. Unfortunately, the funds are sort of, it's a bit soon after coming back from America, and there's other stuff happening. So ideally I want to fit a 3-phase motor and a VFD on this machine, and that'll make it easy to reverse. And it also makes it fairly easy to get a 920 or 960 RPM motor and put on it too, which fixes the horizontal mill problems. And when we gear from here to the spindle on the back, I don't know if you can see that, you probably can't, but there's a big pulley and another spindle pulley, and when we run from one to the other, we're running fast enough through that configuration so that we can run a 3/8 end mill without any problems. So we can fix all this, but what it needs is $500 and some time that is a bit precious too. So unfortunately what I'm going to do is pull this out. I'm going to take it to a friend's place. We might get some footage tomorrow on his Bridgeport, and we're just going to mill this, which is a bit mean, and I'm sorry, because I believe that this mill is more than capable of putting this slot in here, given correct rotation, etc. So let's go and do that.